We finished off talking about individual consumers' demand. The concept of an individual demand curve applies both to goods and to services. Important in the concept of demand is the fact that there's an inverse relationship between the demand that an individual has and the price that they face in the marketplace. In particular, as the price of a good goes up, their demand for that good will fall. By the same token, if the price falls, demand for the good will rise. We also illustrated the impact of a change in income on the position of the demand curve and talked about different types of goods in relation to changes in income. Now I want to shift gears and talk about not individual demands, but market demands. And one of the things that you're going to see is that the concept of a demand curve applies not only to a single consumer, but also to a group of consumers. To get at market demand, we followed a similar kind of process that we used in deriving a market supply curve. Only now we're dealing with demands. And all we have to do is sum up or add up all of the individual demands for the good at a given price. It's easy to look at this graphically with the following diagram. I've got three panels in this diagram. The one on the left shows demand by Jane for the good that we're dealing with. Let's just suppose that this is apples. And so the curve over here on the left shows Jane's demand curve for apples. The panel in the middle shows a demand curve for Fred. And what we see is that his demand curve isn't quite as steep as Jane's. What we don't know is what's the demand curve for the market. And what we'll see is that the demand curve at a market level is simply the sum of how much Jane demands and how much Fred demands. Let's just suppose, for instance, that the price was P star. Because we're assuming that Jane and Fred take that price as given, what we know is that at P star, Jane's demand would be measured by the point where the price intersects her demand curve. And that would lead to a demand of Q1 units of apples. For Fred, we would also determine how much he would demand by looking for where the price intersects with his demand curve. That would occur here, and we know that then that Fred would have Q2 units of demand for apples. To get at market demand, all we do is we add up Jane and Fred's demands, and that gives us the total demand for these apples. At P star, that would lead to some point that would be indicated here by Q1 plus Q2, and we know that that would be a point on the market level demand curve. To get other points in the market level demand curve, we would ask the question what would happen if price were a little bit higher or a little bit lower, and then we would tally up what those individual demands would be at the respective price to get at some market level demand. And if we went through that exercise, what you would do is then connect all of those dots, and you would see that you'd have some demand curve that would look something like this. Now what's important here is that that demand curve goes through this point, and that's telling us that in fact at the price P star, market demand equals exactly the sum of Fred's demand and Jane's demand. And it generalizes beyond just having two people, and it generalizes in fact to having 300 million people if you want. So those market demand curves are very important because they're typically what we look at when we're trying to understand market phenomena. And they reflect something known as the law of demand. The law of demand is simply a statement about the relationship between quantity demanded and the price of the good. In particular, because that demand curve is downward sloping, the quantity demanded is inversely related to the price that the consumer faces. So as the price goes up, demand goes down. As the price goes down, demand goes up. Again, I want to emphasize, demand curves are downward sloping. What's important to recognize is that the position of the demand curve can also change. And in that, we also have to differentiate between a change in the position of the demand curve and a movement along the demand curve. In particular, a change in quantity demanded happens when there is a movement along the demand curve when the price of the good changes, all other things held fixed. So it's simply a movement up or down that demand curve depending on whether price increases or price decreases. This is different from a change in demand. A change in demand occurs when there's a shift in the demand curve because some other factor other than the good's price changes. Such other changes include a change in the price of a substitute or a complement, a change in income, or a change in demographics and tastes and preferences. Now, let's illustrate some of these concepts, and let's start with income. We talked about the impact of a change in income in the context of a demand curve in the previous video, but I want to recap those points and also illustrate the fact that what happened at that individual level also happens at the market level. Now, recall that when income changes, the effect of that change in income on consumer demand depends on whether or not the good is a normal good or an inferior good. If it's a normal good and there's an increase in income, then we know that there's an increase in demand. That is, the demand curve shifts up. So what I've just drawn is an increase in this demand curve from D to D prime because we've assumed that income increases. So that increase in income for normal goods causes an increase in demand. We call it an increase in demand because the demand curve shifts up. If this good were an inferior good and income rose, then what we would see is a decrease in demand. In that case, the demand curve would shift down. And I've illustrated that on the diagram on the right with a shift from D to D prime. We can also examine what happens when there's a change in the price of other goods that might be related to the good that we're interested in. What's important here is whether or not the goods are substitutes or complements. And in fact, it turns out that a rise in the price of a substitute good may cause a reduction in the use of that substitute good and an increase in the good concerned. So what we're really saying is that the demand curve for the good that we're interested in would shift to the right when the price of a substitute good rises. Now this may seem a little bit complicated, so I'm going to tell you how I try to remember this stuff using an example of pizzas and hamburgers. So what I've drawn on the right is the demand curve for hamburgers. We've got quantity of hamburgers consumed on the x-axis and price of hamburgers on the y-axis. And let's just suppose that hamburgers and pizzas are substitutes. You could either consume hamburgers or pizza. And let's suppose that the price of pizza goes up. Well, we know from the law of demand that when the price of pizza goes up, the quantity of pizza demanded is going to go down. But because pizza and hamburgers are substitutes, what's really going on is that the consumer is consuming fewer units of pizza, but more units of hamburgers. We capture this in the diagram by shifting the demand curve up. We say that there's an increase in demand for hamburgers from DH to DH prime. So what I've illustrated is this causal chain of events that the price of the substitute good goes up, the quantity of that substitute good that's demanded goes down. People then move from pizzas to hamburgers, and we capture that by moving the demand curve for hamburgers up. If the price of pizza had fallen, the quantity of pizza would go up, and the demand curve for hamburgers would shift down. There would be a decrease in demand. It's different if we have complementary goods. In particular, a rise in the price of a complement would cause a reduction in the use of the good that you're interested in and the good that is affected by that price. So the demand curve for a good will shift to the left when the price of a complement good rises. And again, let's think about this in the context of a concrete example, and let's use bacon and eggs. Bacon and eggs are often viewed by individuals as complementary goods. So on the right, I've drawn a diagram where I've got quantity of bacon on the x-axis and price of bacon on the y-axis, and I've drawn a demand curve for bacon. Let's suppose the price of eggs goes up. Well, we know from the law of demand that when the price of eggs goes up, you're going to have a movement along the demand curve for eggs such that the quantity demanded for eggs goes down. Now, what will happen here is that people are consuming fewer eggs. But because eggs and bacon tend to be complements with one another, the reduction in the quantity demanded of eggs means that there's also going to be a reduction or a decrease in demand for bacon. And so we capture that by shifting the demand curve for bacon down from dB to dB prime. Now let's think about what would happen if the price of eggs went down. If that happened, the quantity of eggs demanded would go up, and then there would be an increase in demand for bacon, and the demand curve for bacon would shift up. Now, that's not the only thing that can affect the position of the demand curve. There's other factors that are equally important, and one of them that's very important, especially in the context of food and agricultural products, are individuals and, in fact, aggregate tastes and preferences. What I'm really talking about here are utility functions. What do people want to consume based on some notion of what might be in style or in vogue, or what they have developed a taste for over time? Sometimes these tastes and preferences can change, and when that happens, that shifts the demand curve. If tastes change in favor of a good, demand for that good will increase. That is to say, it will shift up, or some people might want to say it shifts out to the right. And so we've got an increase in demand. If tastes change away from a good, people will stop consuming as much of it, and the demand for that good will decrease. It will shift in or shift down. Now, there's also some important differences that have been found with respect to not just tastes and preferences, but the changing pattern of demographics within the population, individuals' attitudes towards health and nutrition, concerns over food safety, the importance of different types of lifestyles, and in fact what's called the life cycle, and as well as the technology that's available to produce foods in the home. I'm going to illustrate some of these points in lecture with a couple of examples to try to put some meat on those bones. So we've just talked about the law of demand at a market level. We've also talked about how we can have an increase in demand or a decrease in demand depending according to whether or not income has changed, or whether the price of a substitute or a complement has changed, or whether tastes and preferences have changed. What we're also sometimes interested in when we're dealing with demand curves is how responsive the quantity demanded is to a change in price. And this introduces the idea of a demand elasticity. So just like how we could calculate supply elasticities, we can also calculate demand elasticities. And indeed, there's very large literature and a lot of work that's been done on trying to measure demand elasticities, because sometimes those demand elasticities are important in understanding the consequences of particular policies. Now, we use elasticities because they provide a unit-free measure on the magnitude of the change you might expect in demand given a change in the goods price, the change in income, the change in the related goods price. Let's focus on the own price elasticity of demand, because this is the one that's usually the most important in the context of the consumption choices that people make. And an own price elasticity of demand is simply the percent change in quantity demanded given the percent change in the goods price. Now you have to remember the law of demand here, because remember the law of demand says that there's an inverse relationship between price and quantity. So that means if the price goes up, demand goes down. So if there's a 1% increase in price, there should be some percent decrease in quantity demanded. What that means is that the own price elasticity of demand will have a negative value. So stated another way, the negative value of own price elasticities of demand simply reflects the law of demand, and that we know that prices and quantities tend to move in opposite directions when we're dealing with consumption decisions made by consumers. Now, we can characterize different demand curves based on the value of the own price elasticity of demand. Now, I've often found that people get confused with the fact that we have a negative sign in front of the own price elasticity of demand. So in developing this table, on the left-hand column, I've actually shown the absolute value of the own price elasticity of demand. And this is intended not to confuse the situation, but just to make the value of that own price elasticity of demand clearer. If the absolute value of the own price elasticity of demand was greater than 1, we call that demand elastic. And what we know is that the percent change in quantity would be greater than the percent change in price should price change. So really what we're saying here is that if there's a 1% increase in price, there would be more than a 1% decrease in quantity demanded. Now you'll note that I said decrease in quantity demanded because I have to remember that the law of demand is important in this. If the absolute value of the own price elasticity of demand equals 1, we have what's called unitary elasticity of demand. When that happens, we know that the percent change in quantity demanded is going to be equal to the percent change in price. Now let's take account of the law of demand, and what this says is that if there's a 1% increase in the price, there's a 1% decrease in the quantity demanded. If the absolute value of the own price elasticity of demand is less than 1, but greater than 0, we say that demand is inelastic. And in that case, the percent change in quantity demanded is less than the percent change in price. I'll go through some examples of this in class and actually bring in some demand elasticities that I've estimated and that other people have estimated to try to make a point about the size of these elasticities, and also to reinforce the point that you can't forget the fact that we have the law of demand that means that there's an inverse relationship between price and quantity, and the change in price and the change in quantity. We also have two extreme cases when it comes to the own price elasticity of demand. This mimics what we had with supply elasticities. We know that if the elasticity of demand equals negative infinity, or an absolute value is equal to infinity, that we have perfectly elastic demand. What that means is that you've got a horizontal demand curve, that the price will be fixed and will not change. If the elasticity of demand equals 0, what that means is that no matter how much price changes, there's no change in quantity demanded. When that happens, we say we have perfectly inelastic demand, and the demand curve would appear as a vertical line. It's at 90 degrees to the x-axis. We can also calculate income elasticities of demand. Now recall that we spent some time in the last video talking about Engel curves and the relationship between demand and income. Well, we can turn those into income elasticity of demand, and it's just a different way of trying to measure the response of consumer demand to changes in income. Now really what we're doing is we're measuring the percent change in quantity demanded given the percent change in income. This table summarizes what we call different types of demands depending on the size of the elasticity, of the income elasticity. If the income elasticity is greater than 1 or equal to 1, we call that the demand for that good either a luxury or a normal. That is, a luxury good or a normal good. And the idea here is that a 1% change in income leads to a more than a 1% change in the demand for that good. If the income elasticity is less than 1 but greater than 0, we call the good a necessity, and it's a normal good. It's an income normal good. So in this case, a 1% change in income leads to a less than 1% change in quantity demanded. If the income elasticity of demand is less than 0, we call the good an inferior good. And so recall from last class that for inferior goods, when income goes up, quantity demanded goes down. So here we know that if there's a 1% increase in demand, there's a negative percent increase in, or sorry, a percent decrease in quantity demanded, and we have an inferior good. Now, what's also important to remember about income elasticities, or to know about income elasticities, is that they'll typically change over income levels. And for most foods, they have small positive income elasticities. That is to say, they're necessities and normal goods. And so we can actually think about how large increases in income might actually lead to changes in consumption that are not as large as those increases in income. I'm going to illustrate this in class on Friday, or if we have a snow day, on Monday, to try to put some emphasis on the relationship between demand for foods and different types of foods and the level of income that a person might have. Now, we also talked about the relationship between demand for a good and the price of related goods, in particular substitutes or complements. We capture that through what's called a cross-price elasticity. And a cross-price elasticity of demand is simply the percent change in quantity demanded given the percent change in the price of another related good. If the cross-price elasticity is positive, we know that the goods are substitutes. And so what's happening there is if the price of the substitute good goes up, quantity of that substitute good goes down, and quantity of the good that you're interested in goes up. So price of the substitute good and quantity of the good that you're interested in move in the same direction, and so the cross-price elasticity is positive. If the cross-price elasticity is negative, we classify goods as complements. And if the cross-price elasticity of demand is 0, we say that the goods are independent goods, that the demand for one good doesn't depend on the price of the other independent good. We'll stop there for now, but we'll pick up with some examples illustrating some of the ideas surrounding trends in relation to consumer demand for different agricultural and food products, and also illustrate how we can use the demand equation to understand the nature of demand's response to its own price, the price of related goods, income, and things like marketing expenditure by firms and organizations.